All right, so in the last talked about linear regression, talked about central dogma of machine learning, training sets, linear algorithm, size of the house, the hypothesis which maps the input variable to the output variable. We talked about on the graph. Then we converted our m and c to theta 0 and theta 1. We showed you that on the graph. Then we looked at cost function and gradient descent. Looked at this a sample training set, right? We looked at how different values of theta gives us different attributes on the graph. We said the idea of machine learning is that we choose theta 0 and theta 1 such that our h of x, which is our output, which is our predicted variable, is very close to y, which is our actual variable for all our training examples. And we said that we measure the accuracy of our hypothesis or the accuracy of our linear regression model, right, by using a cost function. So this is the formula for our cost function, where we said h of x, right, which is our predicted variable, minus y, which is our actual variable, all squared, right? And this is our final formula. So j theta 0, theta 1 is our cost function, is 1 over 2m, the summation of our predicted variable minus our actual variable. And don't forget, h of x is equals to theta 0 plus theta 1x, right? Minus our actual variable all squared, right? So this gives us the minimum value of theta 0 and theta 1. And then we said loss function is used to refer to the error for just a single training example, and cost function is used to refer to the error for all of the entire training set. So let's remind ourselves that h of x, I hope that I wasn't going to have to write this out again, but very necessary. H of x is equals to theta 0 plus theta 1 x. And these are our parameters. Our parameters are or constants are called theta 0 and theta 1, right? Theta 0 and theta 1. Our cost function, which is equal to, which is j into bracket theta 0 comma theta 1 equals to, you should remember this off by hand, 1 over 2m, right? Summation of course, summation because we have more than one data set. So this is our h of x minus y all squared. And then the goal, of course, don't forget the goal is to minimize j, to minimize our cost function, right? Theta 0 and theta 1, right? So let's simplify our cost function by saying if theta 0, right? If theta 0 equals to 0. Because in real life, theta 0 is actually, when you say y equals to mx plus c, this c is usually 0, right? Because our linear regression starts from the origin. So this is our theta 0 is usually always 0, right? So let's simplify our cost function by saying if theta 0 equals to 0, then our h of x equal to, instead of theta 0, we have theta 1x. So we've eliminated this theta 0. So our h of x will now give us theta 1x. Does that make sense? All right. So therefore, our cost function will now be, instead of j theta 0 theta 1, it will be only j theta 1 will give us 1 over 2m summation of h of x I forgot to put the bracket here. Should be a bracket here. H of x minus y all squared. So this theta is going to denote our theta 1, obviously. Right? Right, of course, from here, you remember that when our theta 0 is 0, we always started from the origin. So we're going to start from the origin here. If we add the draw nonsense. So we're going to start from theta 0, right? Once again, if we had a linear regression model where theta 0 was 0, right? Now let's now use this to understand our cost function better. Right? So let's use this to understand cost function much better. Well, let's do it. I just want to show you a graphical example of how cost function works, just so that you have the intuition and it just makes sense. It just makes sense, right? Don't forget, I said we measure the accuracy of our hypothesis of our linear regression model using the cost function. And the idea is to choose the values of theta 0 and theta 1 such that our predicted variable is very close to our training examples or our main variable, which is the basis of machine learning. We want to make predictions and we want to make our prediction as accurate as possible. Sure. So here we have, let's separate this plane into two. Here we have our h of x. Here we have our h of x, which is our predicted variable, right? And here we have our j theta, which is our cost function. Oh, wow. Here we have our j theta, right? So let's draw our 2D, right? Our 2D. For the rest of this course, we're going to be doing 2D just for simplicity's sake. So this is our h of x. Let's say we have a model let me label this 1, 2, 3. Let me label this 1, 2, 3. So let's say we have uh, model where our theta zero is 0. Don't forget. So we're going to start from here, and then our theta one equals to 1. So we're going to have something like this. So this is 1, 1. We're going to have this 2, 2. We're going to have here. This is 3, 3. So here. We're going to have a model that looks like this. So 1 corresponds to 1 on the y-axis, 2 on the x-axis corresponds to 2 on the x-axis, then 3 on the y-axis corresponds to 3 on the x-axis. Sorry. So here our theta 0 is equal to 0 and our theta 1 equal to 1. Right? We can say our y equals to h of x. Do you know why? Why is simple. The question now is that what's j theta? What's j theta? Theta 1, right? Okay, so let's calculate j theta. J theta is 1 over 2m. Then summation of h of x. There'll be a theta somewhere here. H of x minus y all squared. Right? Right. So j theta here will be equal to j theta will be equal to 1 over 2m. H of x, right, is 1. And y is actually also 1, right? So that will be 0 squared. For this second example, h of x is 2 and y is actually also 2. So this will be plus 0 squared plus, for this third example, h of x is 3, right? And y is actually also 3. So that will be plus 0 squared. So altogether, our j theta will be equals to 0. Now, this is the goal of machine learning, to bring j theta to the smallest example, to the minutest value, 0, such that our y, our predicted variable, will be equal to our actual variable, right? Once again, we choose theta 0 and theta 1 such that h of x is close to y. For our training example, we want to make our predicted variables very close to the supplied variables, as close as possible, if possible, the same thing. Now, we had the situation where our h of x was equal to y. Now, let's see what effect it will have on j theta, right? This is j theta on this axis. And on this axis, we have theta, right? So let me label 1, 2, 3. Let me label 1, 2, 3. Right. So we have our theta. This is our theta axis, right? So theta here was equals to 0, right? So theta here equals to 0. Then j theta was around 1. Sorry, theta here was 1, right? And then j theta was 0. So we'll have somewhere here. So theta is 0, right? And then j theta. What am I saying? Sorry, theta is 1, right? 1. And then j theta is 0. So we have our cost function around here. Once again, this would have been the most perfect model in machine learning, right? Because we want our predicted variable to be equal to our actual variable. But now let's take another example. What if theta 1 were equals to 0.5 equals of instead of 1? Right. So let's see how that's going to work out. Let's see how that's going to work out for us. Let's see how that's going to work out for us. So here we're going to have our h of x again. We're going to have our h of x again. And here we're going to have our j theta, with our cost function. This is our cost function. And then here is sorry, this is our hypothesis. Here's our cost function. So here we have h of x. So here we have h of x. What's wrong with my mouse? And here we have y. I didn't label this well. Here we have y. Here we have h of x. Right, so we have j theta here, we have theta here. So let's see how it works out. Yeah. Let me label this 1, 2, 3. Then 1, 2, 3. Now if theta now equals to 0.5, right? So that means we'll have a model that looks like this. This would have been a perfect model, right? 3, 3. This would have been the perfect model where h of x equals to y. But now we have our theta equals to 0.5. So we're going to have something like this. This would be our h of x. This is our predicted variable where theta equals to 0.5. But this would have been this is our this would have been our normal line, right? So let's see, when theta is 0.5, let's calculate our j theta. This would have been our accurate line, just like we had here, right? So let's, just so that we can appreciate theta better. Just so that we can appreciate theta better. Now let's calculate our j theta. Our j theta 1, this is theta 1. Of course, theta 0 is 0, right? So our j theta 1 equals to 1/2m summation of h of x minus y all squared. So this will be what? We have 3 training examples, right? So 1/2m will be 1/2 times 3. That's 1/6, right? Into brackets. This is 0.5, right? Our h of x is 0.5. Sorry, this is 0 minus 1 plus 0 minus 2. Right. 0.5, we have 0.5 here, right? Minus 1. So 0.5 is our predicted variable. Minus 1. 1 is our y, is our actual variable. Minus 1 all squared plus, yeah, we had 1, right? And our y was 2. 1 minus 2 all squared plus, yeah, we had 1.5, and our y should have been 3. So this is 1.5 minus 3 all squared. This will give us, altogether, to give us 3.5 over 6, right? And this will give us 0.58. So our j theta here, our cost function here, is 0.58, right? When theta was 1, our cost function was 0. Our cost function was 0, which would have been the best situation in machine learning. But now we decided to change our theta 1 to 0.5, and now we're having cost function as 0.58. So let's go label our j theta. We have j theta here, and then we have theta here. Let me label once again. 1, 2, 3. So 1, 2, 3. Our j theta, is 0.58, which will be somewhere here. And then our theta was 0.5. So this should lead to somewhere here. And this is our point. This point is where we're going to have our cost function. Don't forget, somewhere here we had our cost function for theta equals to 1. So we had our theta equals to 0. And now we're having our cost function somewhere here, right? So let's go ahead to say, okay, here we had theta 1 equals to 1. Here we had theta 1 equals to 0.5, and we saw what we had as cost function. Now, lastly, let's say if theta 1 if theta 1 if theta 1 equals to 0. So I want you to go ahead and try this example, right? Just pause the lesson for now and go ahead to see if you can solve for if theta 1 equals to 0. Just pause and try to solve. So I'll go ahead and solve it now. So you can see how cost function basically works. So um, so here we have our h of x. Right, and here we have our cost function against theta. All right, so here we have our y, and then we have our h of x. So if theta equals to 0, if theta 1 equals to 0, once again, don't forget our theta 0 is 0, right? That is why we're starting from here, just to make the entire thing simpler. So this is 1, 2, 3. All right, and here this is 1, 2, 3. So 1, 2, 3. Obviously, if this should be our usual hypothesis, right? If we're going to get y back, it should be our usual hypothesis. But if theta 1 is 0, then we're going to have, obviously, it goes without saying, we're going to have an hypothesis like this. Instead of this hypothesis being like this for when we add y equals to h of x, or like this, where we add when theta 1 was 0.5. This is what we're going to have. We're going to have something like this. So theta 0 is 0, and then theta 1 is actually 0. This is what we're going to have. So just to remind you, we had this for theta 0, theta 1 equals to 1. We had this for theta 1 equals to 0.5. So we will have this for theta 1 equals to 0. Now let's calculate our cost function, which is our j theta. J theta 1, obviously. I might not remember to add that. So equals to 1 over 2m. Again, summation of h of x minus y all squared. So what we had is, of course, you can see how far our predicted variable is from our actual variable. It's very far. And this is, we want to avoid stuff like this and see how far it is from our actual variable. So our cost function here is equals to 1/2 times m is number of training examples, right? And here we had 3 training examples, 1, 2, 3. So 1, 2 times 3 into brackets. H of x here is 0, right? 0 minus 1. 1 is our actual variable, right? So that's 0 minus 1 all squared plus h of x is 0. It's on the 0 plane. 0 minus 2 all squared plus h of x here is 0. It's on the 0 plane. 0 minus 3 all squared. So this was 1/6 times so 1 minus 1 all squared is 1 minus 2 all squared is 4 minus 3 all squared is 9. So here we're going to have 14/6, right? 14/6 is what? 2 here 3, 2 here 7. So this is going to give us 2 point something. Let me check. Let me be sure and calculator. 7 divided by 3. So 2.33. So now let's go back here. This is our j theta, and this is our theta. Let me label 1, 2, 3. 1, 2, 3. So here we had theta 1, right? We had our theta to be equal to 0. While we had our j theta, our j theta was equals to 2.33. So we're going to have 2.33 somewhere here, right? So now let's take a combination of all the j theta we've had. Here we had j theta somewhere here. So let me bring it down here, right? And then we have j theta here at 0, right? So basically what we have in machine learning is that we have a combination of j theta that moves like this. It moves in this direction. And the goal of machine learning is to find where theta is here, which is what we add here. The goal of machine learning is for theta to be at the minimum level. We call this the global minimum. because we want a situation where theta is 0. If theta is if theta 1 equals to 0, then it means that our predicted variable is going to be equal to our output, our main variable, right? So we are looking for a situation where we are moving from here to here, from here back here, where we are going to land at this point, right? So this is what our cost function helps us to do. Let me do a recap, right? We choose theta 0 and theta 1 such that h of x is close to y for our training examples. So this is h of x, for example. We want a situation where our prediction for this size would give us 315. And for this size will give us 178. We want a situation where our model will be as accurate as possible. But for our model to be as accurate as possible, our cost function has to be 0. Our cost function has to be at global minimum. But usually in machine learning, you will never be able to get your cost function at 0. But you want it to be very close to 0 as possible, right? So this is going to be the end of the class on cost function for linear regression with one variable. In the next class, I'm going to be taking gradient descent, right? So thank you so much.